Yeah, I guess can you check and see if it's showing up?
Yeah, it may take a second. Yeah, it's back.
Awesome. So it was probably broken for a long time.
Yeah, yeah. Good thing this is a test.
Yep. There was an attempt, right?
All right. It was aptly named, if nothing else.
Yeah. Yeah, there's still two on there. So it
Yeah.
says the automod has been enabled. Oh, the cloner said, FYI, your stream is black. Oh,
Oh,
right.
I don't see anything in the chat. Okay.
Yeah, well. Okay. Well, I appreciate that from them, whoever came to look and see it was all black. Um,
It was a podcast
yeah,
just with a lot
and
of code. It was a code heavy podcast.
yeah, just imagine all the code that's here. Okay, well, um, we have a bunch of code now. It's magic. Uh, let's see. Set this dot head. So we were changing all of these heads into peaks because that's really what it is. And that seems to be working out for us.
Okay.
And
Let's do a test where you push two things on.
yeah,
Well, I guess you could do it in the same. Could you do it
I'll
in the
make another
same?
test.
Okay.
Push twice. Okay, so we pushed 42 and 100. I appreciate the people that said that this is all black. All right. So if I peek at the top, now it should be 100. Even if I push 42 onto there, right?
Hopefully, I don't know if it's gonna work.
Hey, look at that.
What?
That seems to work. Push it twice. Because I'm still
Oh,
only reading off the head. So this is actually, I think, where I need pop.
nice.
because otherwise, like, we can't really traverse to the next one on the list. So, um,
Yeah, we have no traversal.
right. And
Um, Although, like, even though your what's it called, an interface? No, your trait. Even though your trait doesn't have a way to go to the next, I think you could still do it kind of manually, right? Because
oh yeah, I guess I could do that. Um,
well, no, you can't do it manually because the peak does not give you the next. It only gives you the value.
so I do have list dot. I can do list dot head, and then on there I can say that I can say unwrap, which that goes, and this is one that can potentially cause it to blow up with this list head unwrap, and will I don't even know how to put anything on there, but given list.head is a boxed value, or sorry, a option value, you can say unwrap, and it assumes that something's there. If it's not there, then
It's an option. It's an option node.
oh, list.head, yeah, it's an option node, and then
Yeah.
from that node, I should be able to call next, right? And
Yeah.
then in there, I can say next dot value.
Now, but next isn't next also an option node? Do you have to unwrap that?
Let's see, next. Oh, yeah, it is. So why does that value work there? Let's see how this fails. Yeah, so no field value, so you're right. So
Yes.
while it was being helpful for me, now I
If
can say,
only your editor was as helpful as the
right,
test.
yeah. So now it's got unwrapped. And now that I've unwrapped, then I can get the value out of it, and that should be just 100. So I guess I can even,
Does that work?
um, let's see. And it says panic. Try to call option unwrap on none. Yeah, so that seems more like what we're looking for. So,
Oh, right, because
because
head does not have a next.
right, because
Or next is option none.
yes, it is always none. So this push will not work. So in order to fix that, we should see. We need to actually get this dot head or self dot head and put it here, right? On this next.
No, I don't think that's the problem.
Okay.
I think the problem is you're starting at 100. You're starting at the node that has 100.
I'm starting at the node 100, so I should actually be starting at 42. That's the first thing that I want to assert. Because
No.
as I push things on, whatever this is comes to the start of the list. Like it's
Oh,
the head of
okay.
the list. So anytime
I was thinking of it the other way. That head moves nodes.
the head moves nodes.
Like that every time you add a node,
Mm-hmm.
head moves to the new one.
Yes.
That's kind of how I was thinking of it.
And so that's what I'm doing is so like this list.head right here should be the one that
Mhm.
refers to 100.
Okay.
And then I unwrap that and I say next on that node. And I unwrap that and then it should be 42.
Oh, okay. I thought it was pointing the other direction. I thought it was
Oh.
pointing from 42 to 1.
Nope, opposite way.
Okay.
So with that, if we go and let's see, we need to make that pass. And we only have push twice failing, which is what we want. So now our push, instead of just pushing option none on every time, because that is like we're just clobbering head each time. We're not really making a chain here.
Yeah.
This is where we want to say
It's off the chain. We want it to be on the chain.
Right. So we want to give it self.head, and then we actually want to give it a what next needs to be like
It needs to be an option.
It needs to be an option of a box node. So
option of a box node.
Right. So box. But self.head is an option. So that makes for an interesting thing, doesn't it?
You have to unwrap it?
So, but I can't just call unwrap because it may have some value inside of it. Or sorry, it may not. It may be a none. And if it's a none, calling unwrap panics. Like unwrap is like I know for sure something's here. So it's okay for us to do in the test, but it's not okay for us to do right here. So we can do self.head, and then we can do map, which should keep something within an object. So we can say node. So what map will do is if there's something in it, it will go and pass that value and call that call back with it, and then stick it into a new one of those. So if you think of like think of an array, for example.
Yeah.
If you call array.map on an array of 1 and say this map function that you pass to it incremented by 1, you'd get back an array that holds the number 2 in it, right?
Yeah.
You can kind of think of an option the same way. But
yeah.
If you call array.map on an empty array and your function is add 1, what are you going to get back?
Empty array.
Yep. And so option will be kind of the same way, or option.map will do the same thing. And so we can give back a box.new of that node if there happens to be one.
Okay. So we'll have an option box node.
Yep. And then we wind up with this. Cannot move out of borrowed content. And reason being, so if we look at self.head, right?
Mm-hmm.
Then in this option map function, if you see its function signature and you see specifically its call to self,
Yeah.
it's going and it's taking ownership over that,
Okay.
which we don't want to take ownership away from self.head right now.
No. But we
And
do want to mute it,
so
change it, right?
yeah, so what it's really mad about is if we take ownership out of it, for this short moment in time between the time that head has ownership removed and the time that head gets assigned on line 25, there could technically be something that reads from self, right? Like, I mean, like if you're running like say multiple threads or something.
Okay.
So what we can do is we can actually go ahead and say, let's see if this works. If we say self.take and or sorry, if we say self.head is equal to or what? Wait, no. It's sorry, self.head and take. And what take does, let's see if the documentation explains it. So it takes the value out of the option, but it leaves a none in its place.
Huh.
So it doesn't actually remove ownership of it.
So it's like Indiana Jones when he's like replacing that statue with sand.
Yeah, that would. So basically, yeah, it takes a mutable self. So you notice it's no longer taking ownership, and it returns an option T that happens to be a different option that we can pass along ownership to. And so now that this map is taking ownership, it's taking ownership on a new option, and the old option is still in place. Does that make sense?
Yeah.
And
The old option's in place. It just happens to hold a none.
yes, which is okay
So
because
it's
like
not gonna spring the trap.
yeah, like we're gonna throw it away pretty shortly. It doesn't matter that it's a none because we're not gonna use it much after this anyways.
Very tricky.
Yeah, this is a shorthand for there's this like standard mem slash what is it replace, I think it is. Yeah, where you can do the same sort of thing where it does like a bitewise replace, which you can do it with other non-option values, but because it's really common on options, that's where take comes in right here.
Okay.
So if I do that, does the thing pass? Hey, look at that.
Hey.
Did it.
So you might want to change this to the real peak to use peak instead of
Oh, to use peak. Well, I
instead
guess
of head unwrap next unwrap value.
I can't yet
Oh.
because I don't have any way of traversing backwards in the list.
Oh yeah, true.
So I need some pop action, and then I can do it.
Yeah.
So, let's see. Push twice.
Well, shouldn't the linked list have some way to traverse without popping?
Oh, to traverse itself without popping?
Yeah.
You
should be able to start it first and
I
then
mean,
look at next.
I guess the linked list itself would not. We would want something that knows how to iterate over one.
Well, can you do that with traits though?
Yeah, I mean we can kind of do that. Let's do popping first because it'll take a little bit.
Yeah.
I would actually say we should save the iterator part for like another stream that doesn't go black.
Yeah.
And so, yeah. Which speaking of, is still there. I hope. Yeah, look at that.
It is.
Okay. So let's go ahead and implement pop, and we'll implement pop. We'll make it generic, and then we'll call it a night. Sound good?
Yeah. Yep.
All right. Then let's go ahead and write ourselves a test pop function. So if we test pop, okay, we'll have two of them. So first thing we can do is if we pop, we probably want to like return some sort of object, or like we want to return the thing that we pop, right? That's what I would expect. Otherwise, it's just like ripping it off with.
Yeah, exactly.
So
and if you pop on an empty list, you should just get an option
none.
of none.
Yeah. So let's do that first. So I'll even say test pop empty, and I'll leave it mutable because we're going to be making changes, or at least trying to. So we'll say list.pop, and we will assert that that is an option none, because that makes this one easy to implement.
Yeah.
So let's go ahead up to our implementation here, say function pop, and we'll take in a, I don't know, mutable self, and it doesn't take anything else, but it does give back an option of U32 and returns an option none. Save that.
And no semicolon means it returns, right?
Yep.
So weird.
And yellow squigglies mean that this thing is just warning at me.
It's warning at you?
Yeah, so it gets telling me that this method is never used because
little does it know.
Well, yeah, like I guess it doesn't know about tests. Like that's part of why. So it's okay though. I'm not too worried about the yellow. But it also will warn about other things, like it'll say that. So even if it said like if I said it was public, yep, just pub, not public, but
just pub. Yeah,
yeah. But then it also follows the fact that like even though it's here, it's never exported anywhere else. But we'll make that happy later too. That's not that big of a deal.
If you do pub for public, how do you shorten publish?
Publish. Maybe you just go for full-on pub.
Publi.
Yeah.
Pubble.
I don't know. But hey, look at that. We tested pop empty. That's working great. Okay.
Awesome. Let's do something more interesting.
Yeah. So.
Push something on there.
Yeah.
What do you call this? Test push and pop. Just like push the letter in and pop. Push and pop.
Push and pop. Yeah. All right. So let's go ahead and list that push and put on 42 because that's our number of the night. Say option sum 42.
Yep, and fail.
We should have a failure. Yep, we're getting none back. If it worked, that would be impressive. But all right, so we need to pop off of this thing, and the let's see how we can do that. So
you're gonna take self dot head.
Yep, we'll say self dot head, and we're gonna set it equal to something because we definitely want to rip off whatever's there, right? I guess we'll even we want to read off of self head, so we'll say like result or something like that, self head, and then we want to like get a value off of it potentially.
Yeah. Okay. So this is. I think that I'm not sure you're going to do this, right? Because head does not have a reference to the previous node.
Head does not have, but its node does. I mean, there won't be a previous node.
Oh, it has a next.
Yeah. So it.
Okay.
Yeah. So if
I keep thinking
there
it's
is
going
one,
the wrong direction.
Yeah, it will have a next. And what we can do, let's see, I think anyways, is if we say self.head and we go ahead and if we say map, because if we get it, we want to give back an option with a value on it, right?
Yeah.
So let's try that first. So, because all we're asserting is that. So if we say self.head.map, and we say node, if there happens to be a node on it, right?
Yeah.
Then, because we're not even caring about assignment of what the new self head is. We have no tests that care about that. But we can say
Right.
node.value. How about that? All right, now we're getting that age-old cannot move out of borrowed content. Once again, this happens from the map call. I wish that it pointed a little bit more to that map call, but either way, this is not a stellar thing, but we'll try it out. So self.head, and then we'll do the take again.
Yep.
So we'll go and swap it out, and now we're passing with our push and
Okay,
pop.
so that means we didn't write a very good test.
Well, we did. I mean, we asserted that it passed. So
Right, but so it's popping. This is doing the same thing as peak, right?
it's doing the same thing as peak.
Right.
Well,
because if you pop again, you should get an option of none.
let's go ahead and I think with this push twice, this will like prove it out for us. So
Okay.
I don't care too like, and we have a push one. What would you be in favor of, like copying this test or? Yeah, let's go ahead and we'll copy it instead of changing the test, and then we'll get rid of the other one afterwards because we'll prove the point. So instead of doing this like gnarly unwrap stuff, we'll go ahead and replace it with some pop calls instead. So what we should be able to do now is, given we're in this state, we should say list.pop to equal option sum of 100.
Yep.
And then we expect it to be 42.
Yep.
And then
none.
None. So we'll write that test.
Okay.
Push.
Same name.
Yep. Double.
Double push twice.
Double push and pop. All right.
Double push and triple pop.
Yeah. Okay. If we.
Did you ever eat those push pops as a kid?
Yeah, you get like gross fingers that get all sticky because your saliva would seep through the cracks and. Like,
yeah.
Yeah. But yep, I know what you're talking about. Same for like ring pops.
Oh gosh.
Yeah, and you couldn't do anything once you opened them. Like you just couldn't put it back in the bag because it'd stick to it.
No.
So right here we're failing on the 42 case. Like it, and you would expect that one to work, right? At least initially you would think.
Yeah.
But what's happening, as far as I can gather, is right here we're going with our pop and we're saying head.take and swapping out the head for its sum for a none. Right here it's doing that.
Yeah.
So the first time we call it, which is with 100, it swaps it out for a none and then carries on with its business, right?
Mm-hmm.
And we don't really want that. Or at least the take is a little bit of a problem because we're not assigning the next node to the head.
Yeah.
And so it's becoming none from underneath us, or like it's getting swapped out, and we're never using node.next. Like that's I guess kind of the key thing is like node.next is not used anywhere in here.
Right.
So I wonder if we can do let's see. Because if there is a value, then we want to actually go and say like is that, and I won't be okay. Let value is that, and then we will say self dot head is equal to node dot next, right?
So self in this case, inside those squiggly brackets, is that a different self than the self on line 32?
No, it's the same.
Same one. Okay.
And then we get back value.
Okay. So when you call take, it gets swapped out for a none, but then you replace it again with value.
So we found standard box. Yep. So now it is mad because we have like node.next is a box, and you would have to go and get that value out of it.
Oh yeah.
And so we'd have to what we'd actually wind up doing here that's a little weird is that we would be like taking that out of the heap and putting it onto the stack. Like that's a very like I guess memory centric sort of way of thinking about it. But to read out of the box, you can if you want to read from a box, you can do that deal. I think it is.
Oh, that reminds me of C.
Yeah. Type node.
Node cannot be dereferenced.
Oh wait, hang on. What is it? Then what is it mad about here? Box node cannot be dereferenced. It can't be. What is it?
It refuses.
Really? I don't think that's it. I think that's not true.
It's kind of weird that as you're mapping over self.head, you're assigning a value to self.head.
So that as I'm mapping over it.
Yeah.
Yeah, it's. I
That's
mean,
odd.
I guess we're doing mutation here, so it is a little bit more. Okay, but yeah, I see what you're saying. I'm trying to figure out, like. Let's see. If I go to the not that. Box. Standard box. Oh wait. So next is an option of that.
It's an option box.
Yes. So it is an optional box. It may not actually be boxed. Or,
Right.
Sorry. It may not actually have anything there.
Right.
So,
yeah.
So in that case, we need to get the value out of it, right? If there is a value. Otherwise, it's cool being a none.
Right.
So if we say next.map.
Well, it's cool with being an option none.
And I don't know, box. Yeah, it didn't like the word box because box also used to be like a keyword in Rust, so I'm not gonna mess with that. So we'll go with B, right?
Yeah, stay outside the box.
Yep, and B should give us back that thing. Hey, look at that! I got yellows, which means like it didn't fail. Like it.
And you're dereferencing B.
Yes. So I'm dereferencing the box. So I'm reading the value off of the heap and putting it onto the stack.
So dereferencing just means you're reading the value off of.
Yes. So I am following the pointer that the box has and taking that and putting it onto the stack. Like following that pointer, taking the value, putting it onto the stack so I can use it.
Cool.
All
And
right.
it's passing. It's green.
Yeah, look, we did it. Okay. So I want to make that thing generic. If you're good with that. I don't know how you're doing on time.
I'm good. So instead of U32?
Yeah. We'll see if we can take,
Okay, so do we want them we want the linked list to contain all of the same type, right?
mhm.
But we don't really care what type it is.
Yep. Yeah. Like U32 is, it's, I guess, easy for implementing right off the bat, but we'll follow it along. All right, so let's say linked list takes in a T, and our nodes have to have a T on them, right? Like,
Yeah,
because that's T is the type of value that we got going on here.
that is an option of node of T.
Yep. And so node needs to take a T right there, and its value is going to be a T, and
Yep,
this is going to take a node of T,
yep.
and then linked list is going to take a T, which to make it work for an
So,
impl, you have to take a T there too as well. Lots of T's all
okay.
over.
So even the impl is of T.
Even even the impl is of type T. Okay. And then here, this peak happens to give back a T.
Yep. Push item is a T.
Mm-hmm. So far, we're less red. Okay, and then
Option pop returns an option of T.
all right, cannot infer type for T, which is expected because
Because we're making a new one and not telling you what type.
yep. So we can say linked list, and I think we're already testing new. We'll make it pass. I'll leave this around for you. All right, U32. So we'll go back to that U32 still. That's fine.
So you're having to explicitly declare the type here because it can't just look at that new and know what type it is.
Yeah, like there's never any hinting as to what type it is, so I have to tell it. There might be a way. Can I do this? Hang on. Actually, let's make it pass. I'll fight more with the syntax. All right. So it's mad on line 53 because also I'm doing the same here.
Yeah, every single test you're doing that.
I know it is smart in some cases though, that it will just figure it out.
Oh, really?
I think so.
So since
Yeah,
you're pushing,
because it's fine here on 66 because I'm actually pushing values into it.
oh, that's interesting. So the compiler can look ahead and then
Mm-hmm.
work backwards from there to realize what type it was.
Yeah, that's the like Hindley-Milner, I think it is, type system, where it can go and based on usage infer what type something is, which is really nice. So in the general case, you don't have to. The only time that you do have to explicitly declare is when there's no other indication of what its type is.
Yeah.
All right. Cannot move out of borrowed content. Okay. So, this happens to be an issue.
Hmm.
Let's see. So we have a reference to node. So we're borrowing off of node, but we're moving value off of it entirely. So it probably was that U32 is copyable. So
Because
U30,
it's like a primitive type.
yeah, and so it's no big deal for that thing to be copied out. So
Yeah. Can you just dereference it here?
can I dereference node dot value?
Yeah.
But if I peek at it, do I want to do that though?
Oh,
It,
I don't know.
yeah. Maybe we go and find a better way at this in the future. But if we say that T has the trait of clone, then what do we got here? All right. Okay. I have to do that in a couple places. Is it here? If we say it's clonable, I'm gonna work from that front first.
Interesting.
And we can say node dot value dot clone. And that might make it pass. Okay. So, like the clone interface says that like you can call dot clone on that thing and make a copy of it.
Okay.
There's got to be a better way of it, but for the moment, that's what I'll work with, is that you have to do it, because I'm sure there's some other way of. I mean, I guess probably what I want to do is not actually return an option of t. I just want to let you see a reference to it. Yeah, maybe
Oh,
that's what I
yeah.
need to do. Like, because we don't want to give away the value, right? Just
Right.
walking
Yeah.
back to actually what's going on here is like we don't want
Just
to.
we're just peeking at it.
Right. So
Just a
and
little peek.
right, and so we should be able to say that we're giving back an option of that kind of t.
Ah,
Is
that's
that
interesting.
okay? Expected ampersand t. So if we say, all right, here's that value, does this work?
Ooh.
Ah, okay, okay. There we go. That's more of what I'm looking for. And then what it's saying here is that like we're expecting our peak.
Specs an ampersand integer found an integral variable.
Yeah. So it's expecting a reference to an integer of some sort, but it found like a hard type. Like
Okay.
so
Yeah.
sum of 42, which line is that on? 61. Okay. We'll go up and fix it right there. So it should actually be a borrowed 42.
Okay.
Because that actually lives as like part of the type information on it. Boom.
Nice.
Which I mean that makes so much sense though. Like why do we have to make a copy of the thing when all we're doing is saying like you can take a look at this?
Yeah.
Cool. That that makes me
And
feel
you should even be able to go down to your last test and you could peek like after that anywhere in there you can do a little bit of peeking as well.
oh yeah. So if I were to say like peak option sum of ampersand 100, right?
Yeah.
Here, I'll let it fail first so I can, but
Yeah.
yeah, so you can take a look at the value. You can borrow that for a minute, but
Very cool.
yeah, yeah, I feel good about that. I mean, I guess good that we made our test pass. As for the quality of the Rust code, that is something to be seen. But um,
Yeah.
next time we can go ahead and not have black videos, and also we can go ahead and implement. There is an iter type interface, so
Yeah.
that lets you go and iterate over something, and then that gives you access to all sorts of really cool stuff. Like you can do like mapping and reducing and all that, and all you have to do is implement like one function. So this iter standard iter, and then in parameters, and then there's like a, not necessarily a B tree map, because I don't want this struct, I want a trait. But yeah, there is standard iter. There you go. And is the iterator. There we go. So you like the iterator, like you have to go and implement next. Like that's your required thing. And you always have like you have to return an option of something. And so like here's this array, or then we say array.iterator, which gives us a mutable iterator, because if you think about it, like every time you call next on an iterator, it goes and mutates it, right?
Yeah.
And so every time it's next, next, next. So it's mutating it under the hood, and each time it gives back a value off of it.
Nice.
So we can definitely pull off something like that on the next run.
And once we fully have a linked list, and then we can implement a queue with it, no, a stack with it. And then once we have a stack, we can use 2 stacks to make a queue.
Yeah, we can work from the ground up. It'll be hyper performant. Did you go and read about how?
Before you know it, we'll be launching Rocket.
Yeah. Rocket is a Rust web framework.
Oh, okay.
And that's already been launched, I guess. But
yeah.
Did you read about the how to implement a queue in terms of 2 stacks?
Yeah, well, not in depth, but I thought about it.
Yeah, having like the inbox and the outbox type one.
Yeah.
Yeah, we'll have to do that, because once we have our linked list, we basically, or we do have a stack, because we have push and pop and peek, which are very stack-like. But,
yeah.
All right. Well, with that, I guess I'll go and end this. It was